Okay, so I think I'm supposed to accomplish 5.6 number 1 by reduction of order because you guys reminded me what I was doing, which is good. Okay, so how does one execute reduction of order? To my recollection, you variation of parameters, basically.
Yeah, we stop a u on the y1.
Okay, so you let, like, kind of guess y is mu times e to the minus x?
Yeah.
Yeah? And then what?
Then you derive that twice.
Then you differentiate this a couple times. So you get y prime is mu prime e to the minus x minus e to the minus x mu. Yes?
Okay, I just have a question because I seen how Mark was doing it, and he left it as y1 instead of e to the minus x.
Sure.
And so after I differentiated and after I looked at his differentiation, when you plugged him back in, I originally went with your plan, and it was like pretty narbar. So I pretty much just quit before I even did the algebra. Then I'm gonna try it his way though. So I just don't know.
Okay.
I just left it as y1s because then it's the same thing every time.
Sure. That's reasonable. Yeah.
And you keep your addition
Um.
right there.
Yeah. Sure.
I just don't know, like, is that?
Yeah. Either way is reasonable. I guess I would personally lend myself towards this one just
Just because you don't have to plug back in the end?
for randomness. I don't know.
Okay.
There's not a good reason to do it. Like one way or the other is they'll both be the same.
Okay.
If you do the one with y1, you'll have fewer symbols to push around, but they'll be more abstract. If you sub in what y1 actually is, you'll have more symbols, but they'll be more concrete.
Yeah. So at the end of it, you have more, less
Yeah.
to plug in.
It doesn't particularly matter.
Okay.
I'll go with this approach because you said this one was worse, and if it is,
It
then
looked
I'll
worse,
recommend the
definitely.
other approach.
Yeah. Okay. Works for me.
Okay, so if I do y double prime, then I get mu double prime e to the minus x minus mu prime e to the minus x. And then this part I already differentiated, right? So I could just do minus this whole business. So I got a minus mu prime e to the minus x plus an e to the minus x mu. Okay, and then I can notice,
You got 2u prime e to the negative x.
okay, I got two of those. So I could rewrite this as mu double prime e to the minus x minus 2 mu prime e to the minus x plus mu e to the minus x. I don't know why I keep switching where I put that one. Sorry. That's just because my brain's not working yet. Okay, then take this guy, and that guy. Shove those into your original. So I'm going to call the original star. And then I'm going to say star evaluated at y becomes this whole business. Mu double prime e to the minus x minus 2 mu prime e to the minus x plus mu e to the minus x. Oh. I needed all of that times 2x plus 1, right?
Yeah.
Okay, so I'm going to do this. I'm going to go 2x, that stuff, minus 4x, that stuff, plus 2x, that stuff. So there should be a mu in there still. And then plus that stuff again. So mu double prime e to the minus x minus 2 mu prime e to the minus x plus mu e to the minus 2x.
So this is actually where if you leave it as
Yeah, this is probably a good spot.
really easy to see the y1s are going to, the y1 double prime, the y1 prime, the y1 just, you can see easily where they chop off.
Yeah, that's probably a good point. Yeah,
It's gonna go.
this would suggest the other way.
All the way up.
I'm going to just continue this because I already started down this path, but yeah. And then I need minus 2 y prime, so I need a mu prime e to the minus x plus 2 e to the minus x mu. And probably I should denote what parts are what, but I guess I'm not going to. And then I have minus 2x plus 3 times that. So I got 2x mu e to the minus x minus 3 mu e to the minus x. right?
Yeah.
And this whole thing is supposed to actually equal, right, like all this jazz added together is supposed to equal 2x plus 1 quantity squared, right? Okay, so now I'm hoping something's going to cancel. And really a whole bunch of stuff should cancel.
Anything with a mu, right?
Yeah, so I should watch the mu's drop away. So let me, I don't know, group up the things with mu's in them. So here's a mu e to the x. Here's a mu e to the x. Here's a mu e to the minus. I keep saying e to the x, but it's even minus x.
In the textbook, it said that, like, just looking at that, you could know that it was the q naught x times u double prime plus q1 x times u prime, and then explain that q naught was p naught, and you multiply that by y1. Can you just do that like all the time? You don't even have to.
Yeah, if you happen to remember exactly how this works or have it written down on a sheet of paper that's convenient to you, yeah, do that.
Okay.
That's totally reasonable. Like here, I'm just noticing that some cancels, right? That's essentially the same thing.
Okay.
So yeah, if you remember what the form looks like, great. Let's see, and then I got mu, so I got 2x mu e to the minus x, and here I got a plus that, so I can drop those guys. And then, let's see, what else I got?
I think it's good for the mu's.
That certainly looks like that's it for the mu's. So I have here a, let's see. All right, so I have a 2x mu double prime e to the minus x. And then where else do I have a mu double prime? So I got a mu double prime e to the minus x there. So that's this one and this one accounted for. And then on the mu primes, I have
minus 4x mu.
minus 4x mu prime e to the minus x. That would be this guy. And then I have two matching ones left, right? So I also got a minus 4 mu prime e to the minus x. And that would be this guy and that guy added together.
Cool.
Pull that?
Some stuff on the way.
Some stuff went away. And then this whole thing is supposed to be 2x plus 1's quantity squared. And now what?
You can multiply by e to the x, everything.
Okay. Also, I should probably do this, right? Make your substitution at this point. Because now you have double primes and mu primes, right? So really that's first order in mu prime. So make that substitution. And then rewrite. So I can multiply through by an e to the x. So I got 2x z prime plus z prime, plus z prime. So here I'm also multiplying through by e to the x. And then I got a minus 4x z minus 4z equals 2x plus 1 quantity squared times e to the x. And then really I multiplied this junk out a little bit. Probably I should factor it back a bit. So I think I got a 2x plus 1 times z prime minus
4x plus 4.
maybe plus, oh no, minus 4x plus 4 times z is this thing.
I'm liking the look of that 2x plus 1.
I'm liking the look of that 2x plus 1 too. In fact, I'm liking the look, I really wish that was a 4x plus 8, don't you?
Yeah.
Or 8x plus 4.
Yeah.
Did I screw that up or is that just the way that is? That's just,
No.
it's kind of a bummer, man. It's that kind of thing that I see in a textbook and I'm like, I probably made an algebra mistake. If I was on my own with this, I'd spend a while hunting for it, but it sounds like you guys did this.
We hunted like you.
Oh, and you hunted around for it, okay. So let's see. I need my original sub, right? My original guess, and also my blue thing. Those need to go off in the margin, so I don't accidentally lose them. Okay, so what do you do with this thing?
Divide by 2x plus 1 to isolate the z prime.
Okay. So you got z prime is z prime minus 4x plus 4 over 2x plus 1
So
times z, rather.
So 2z.
2z. That's why I wish this was an 8. Or this was a 2. Right? It doesn't quite cancel out how you would really hope for it to. But on the other side, one does. So on the other side, you get 2x plus 1 times e to the minus x. Plus x. Okay, then what?
Solve the homogeneous.
Solve the homogeneous one. Okay, so the homogeneous one is ZH, right? Which is
E to the
4x plus 4. Oh, do you want to do it that way? Okay. All right, fine. So homogeneous version, ZH prime minus this crap.
now z. Z homogeneous.
You just want to jump straight to the solution, man.
Absolutely.
All right, Z homogeneous is
E,
E?
to the negative integral of 4x plus 4 over 2x plus 1.
yeah.
Sure.
Positive integral is minus sign.
There's a minus sign built into the formula, right?
Because you have to, yeah.
So that formula should be, this thing is a p of x, right? Like that whole coefficient's a p of x, and then it's e to the minus integral of p. So I got a minus minus. All right, so then what?
It'll be easier to integrate if you split the top.
Okay.
If you call it 4x plus 2 plus 2.
All right, so now I'm doing the sub problem of integrating 4x over 2x plus 1.
No, 4x plus 2 over 2x plus 1. Yeah.
Oh, that's cute. That's beautiful, guys. Good work. Okay. And then this piece is
2.
2.
After you raise 2x.
Okay, so I got 2x plus, how do you integrate that one?
It just so happens to work out nicely in natural log of 2x plus 1.
Cool. Yeah, so you do u substitution, right? You do u is 2x plus 1, then du is 2 dx. And so there's your du. So you got 1 over u. So you get natural log of the absolute value of 2x plus 1. Oops. That was supposed to be an absolute value bar. And then you need to worry about your constant.
No.
Yeah, make it 0, right? Because you're just using this thing to get the particular solution that you're trying to integrate anyway, right? Okay, so I think I got here that my homogeneous solution was e to the 2x times e to the natural log of the absolute value of 2x plus 1.
That'd be 2x plus 1 times e to the 2x.
So I think I got the absolute value of 2x plus 1 times e to the 2x, right? And I would really hope that they had said something about like, well, let x be bigger than minus a half or something, so I didn't have to bark around with this absolute value bar, right? Okay, so I think in the end here I got z homogeneous is the absolute value of 2x plus 1 times e to the 2x.
Times the integral of 2x plus 1 e to the x over absolute value 2x plus 1.
Okay, so you have variation of parameters formula down someplace. Okay, so what do you get? So I got this thing.
That thing.
So you should be doing variation of parameters, right? And maybe at this point in my life, the appropriate way to do variation of parameters is to look up the formula quick.
Integral. 2x plus 1 e to the x over absolute value 2x plus 1 e to the 2x. Cancel out e to the x from top and bottom.
I don't know, I'm just trusting him. I don't remember the formula. Should I be trusting him?
It's f over what?
It's fx over yh.
Yeah, I think it's the integral of f over the forcing term divided by the homogeneous solution. I believe that. Okay, so I got this, which, oh gosh. So, over here. Oops, I lost it. Never mind, I wrote it over there. We're good. It's all good. So I think I found that z is the absolute value of 2x plus 1 e to the 2x times the integral of, what's 2x plus 1 divided by its absolute value?
Plus or minus 1?
S. That is either plus or minus 1. And e to the x divided by e to the 2x is e to the minus x. Hilariously, it is my profound belief, which is not motivated possibly by facts, that the plus or minus 1 in the integral and the absolute value bars out here should roughly cancel. Please note,
So
that
which
is
value-
not motivated by math right now. That is motivated by the sheer laziness of that I don't want to think very hard about that part of this problem.
So does that
So-
become just a 1?
It is possible possibly,
Gut feeling?
I'm gonna write that on the test.
z is 2x plus 1
That's
times
my gut feeling.
e to the 2x times, what's the integral of e to the minus x? Negative e to the negative x.
So,
Plus
Plus c.
Now, would that be C1 at this point?
then we integrate that, right? Like good are you?
Yeah, so at this point, hang on, if I simplify this a little bit, I got 2x plus 1, right? Times, minus,
Yeah, minus.
how about 2x times minus times e to the x
Uh-huh.
minus times 1 times e to the x plus constant. The reason I'm splitting here is that I'm going to have to integrate this thing anyway, right? So I may as well distribute right now. So that's z is this thing, and that's for the record of 2. Okay, now I should go back to the very beginning, the beginnings. No, this was like halfway through. Halfway through, z was mu prime. So mu prime is minus 2x e to the x minus e to the x plus c1. So that would mean that mu is
Negative 2 times x on x minus x, I think, is the, we've done that a million times, I think it's like parts on x e to the x.
yeah, that should be 2 parts on x e to the x. Somebody want to tell me what you'd get out of parts?
Oh, sorry, x e to the x.
God damn it, don't make me do integration by parts.
I'll plug in.
All right, so I want to integrate x e to the x, right? dx. So I let u be x,
X.
and I let dv be e to the x, dx.
X.
So v is e to the x, and du is dx.
So you have
So that's,
X e to the x minus the integral of e to the x dx.
cool, minus e to the x. Okay,
Things minus 2.
thanks for nothing, guys. So I got minus 2x e to the x minus e to the x minus e to the x plus c1x
Plus C2.
plus c2.
Oh, never mind. I was like, we gotta integrate that, but then it's just the same.
You just plug that into y equals mu times y1.
Yes. So then that goes back in the original substitution. I think for those keeping track at home, there were something like 12 different variables in this problem. Right? Because I did at least a u substitution, I did at least an integration by parts, I did variation of parameters, I did reduction of order, which requires kind of a variation of parameters, and another substitution. I think that brings me to,
Don't forget integration by parts.
yeah. So 2 variables for integration by parts, 1 for u substitution, 1 for the variation of parameters in the middle, the z,
Don't forget
The
the x
or-
and the y. And the z homogeneous.
oh shit, there was a z homogeneous. Okay, so there's that one. Yeah, I think I'm to
And a y
8
one.
or something.
Oh, the joy.
Okay, at any rate, at the end, you get y is that whole pile of stuff minus 2x e to the x plus 2 e to the x minus e to the x. Oh, cool. That would be a plus e to the x
Plus C1x plus C2.
plus c1x plus c2 all times e to the minus x.
Probably distribute that.
No.
I mean, it's at least that one's not that.
Circle done.
But if you,
But if you distribute it,
But
then instead of having 2 e to the x's, you'll have 2 e to the minus x's. Who cares?
I guess it's true.
Like, yeah, sure, you can distribute if you want.
No, I mean, if you're fine with it, so am I.
Yeah, I would advise for, per
on
usual,
record.
do as little work as humanly possible. This thing was enough work already. Cool? Questions, things? Like, that's just a ton of work, right?
Yeah.
Why is this number one?
I don't know.
This is the first problem in the section.
Yeah.
But then the other ones were easier, right?
Oh, yeah.
I don't know.
Okay, so I will add that to my list of things.